Please see the link in the description to download a worksheet for this video. If you've not already done so, we suggest that you watch the video on how to calculate the areas of squares and rectangles before watching this video. Your 5th grade state math exam may have multiple questions that ask you to calculate the area of a rhomboid or rhombus. These may be fairly easy compared with other questions. You may find it takes less time and effort to answer these questions correctly compared with other questions on the exam. In this video, we'll learn how to calculate the area of rhombuses and rhomboids. We'll learn what a rhombus is, what a rhomboid is, how to measure the height of a rhombus or rhomboid, the formula for calculating the area of a rhombus or rhomboid, how to calculate the area of a rhombus or a rhomboid, types of parallelograms, and the one formula for calculating the area of all parallelograms. Let's start with learning what a rhombus is. This is square. We know that because each of the 4 wooden sticks are the same length and have 90-degree angles. As a reminder, a 90-degree angle is the angle between something horizontal, like this stick, and something vertical, like this stick. If we push this square over a little bit, then it loses its 90-degree angles in each corner. So we change its name from a square to a rhombus. But please note that the top and bottom sides are still parallel to each other, and the left and right sides are still parallel to each other. Please also note that the length of the sides never change. So they're still all the same length. As a reminder, the word parallel means when 2 lines stay exactly the same distance apart, so that they never cross. The most common example of parallel things are the rails on a railroad track or the pickets in a fence. Next, we'll learn what a rhomboid is. This is a rectangle. We know that because there are 4 wooden sticks that make 90-degree angles in their corners, but the sticks that are next to each other are different lengths. For example, this yellow side is short, but the 2 green sides next to it are long. If we push a rectangle over a little, it also loses its 90-degree angles, so we change its name to a rhomboid. But please note that the top and bottom sides are still parallel to each other, and the left and right sides are still parallel to each other. Please also note that the length of the sides never changed, so the shorter ones are still equal to each other, and the longer ones are still equal to each other. Next, we'll learn how to measure the base and height of a rhombus or rhomboid. Here's a rhombus. We call the length of the horizontal side the base. In this case, it's 8 inches. We measure the height with this tool. This tool is made of metal that's like the capital letter L. It forms a perfect 90-degree angle. We then read the height of the rhombus on the vertical side. In this case, it's 6 inches. If we were to draw a picture of this, we get this. On a test question, you'll often see a dashed line with part of a square at its base and a number next to it. This dashed line is like the metal tool. It is telling us the height of the rhombus. The dashed line is not part of the rhombus. When a question is asking about the area of a rhombus, sometimes the test makers may color in the center like this, but sometimes they won't color it in. Here's a rhomboid. As with a rhombus, we call the length of the horizontal side the base. In this case, it's 8 inches. We measure the height the same way as with a rhombus. Specifically, we find the vertical distance from the bottom horizontal line segment to the top horizontal line segment. In this case, that distance is 2 inches, so the height is 2 inches. As with a rhombus, on a test question you'll often see a dashed line with part of a square at its base and a number next to it. That dashed line tells us the height of the rhomboid. Similarly, you'll often see the center colored in when the question is about calculating its area, but not all the time. Next, we'll learn the formula for calculating the area of a rhombus or a rhomboid. The area of a rhombus or rhomboid equals the base times the height. This formula may sound familiar because it's the same formula for calculating the area of a square or rectangle. Now we're ready to solve 2 practice problems. Here's a rhombus. The base is 4 inches. The height is indicated by this dashed line, which is 3 inches. To calculate the area of a rhombus or rhomboid, we do 3 steps. Step 1. Write out the formula. Area equals the base times the height. Step 2. Substitute the words with numbers. In this case, the base is 4 and the height is 3. Step 3. Do the calculation. 4 times 3 equals 12. So the area of this rhombus is 12 square inches. Here's a rhomboid. The base is 7 feet. The height is indicated by this dashed line, which is 2 feet. To calculate the area of a rhombus or rhomboid, we do 3 steps. Step 1. Write out the formula. Area equals the base times the height. Step 2. Substitute the words with numbers. In this case, the base is 7 and the height is 2. Step 3. Do the calculation. 7 times 2 equals 14. So the area of this rhomboid is 14 square feet. Our final topic is to talk about parallelograms. On your tests, you may see questions that refer to a rhomboid or rhombus as a parallelogram. The word parallelogram is a general term. Examples of parallelograms are squares, rectangles, rhombuses, and rhomboids. We call these parallelograms because they have some features in common. They all have 4 sides made of line segments. The opposite sides are equal length, and the opposite sides are parallel. Here's a square. We can see that it's a parallelogram because it has 4 sides made of line segments. The opposite sides are equal to each other, and they're parallel to each other. Here's a rectangle. We can see that it's a parallelogram because it has 4 sides made of line segments. The opposite sides are equal to each other, and they're parallel to each other. Here's a rhombus. We can see that it's a parallelogram because it has 4 sides made of line segments. The opposite sides are equal to each other, and they're parallel to each other. Here's a rhomboid. We can see that it's a parallelogram because it has 4 sides made of line segments. The opposite sides are equal to each other, and they're parallel to each other. As we learned previously, the formula for the area of a rhombus, or rhomboid or square or rectangle, is that the area equals the base times the height. We just learned that rhombuses, rhomboids, squares, and rectangles are all in a group called parallelograms. So we can simplify this statement by saying, the formula for the area of a parallelogram is area equals the base times the height. Thanks for your attention.